Hey, hello everyone. Today we are going to solve this problem of the day from GFG string permutations, and they have marked it as easy level. So we have been given a string S, and the task is to find all permutations that need not be different for the given string. So since we do not need to take care of the repetitions, so basically if the length of the string is 3, then the possible permutations will be 3 factorial, that is 6. For 4 it will become 24. So we can see the constraints that the size is not very big, it is lesser than 5, and the complexity expected is also n into n factorial. So this simply means that we can make use of recursion and backtracking. So just to take it just to make it a bit more interesting and cover another topic, I will also use bit masking here, and you will come to know how. So first of all, we will have a answer array, and then we will call our function with the given string. Let me just okay, S. Then I will have another string, maybe. Okay, let's first define our function itself. So it should be void solve string as string current. Then we also want the index, the current index, or maybe it's okay if we take another parameter, or we can make use of current or size as well. So apart from that, I will have a bit mask, and yes, finally the answer. So vector string answer. Fine. So first of all, the base case, if index, that is if index is greater than s dot size, then we will just push back the current string. That means that the length of current is equal to the required length, and we have made use of all the characters, so we can push back this current string into our answer vector. Fine. Now let's start with the permutations. So we will say I equal to 0, and then I goes up to s dot size and I plus plus. Now suppose this is ABSG. So ABSG. So when we are on index 1, we can make use of any of the 4 characters. So that's why I am iterating from 0 to s dot size, and I will push back any of these numbers. So there would be a condition, some condition that checks that we haven't used the character at that place, and then if it has not been used, we will just push back that into our current string. So that character will be pushed back. Then we will call the solve function again with the updated parameters. We have pushed a character into our current string, so the size increases by 1. So we move to the next index, and we will do something to the bit mask as well, and finally the answer. Fine. And once we are done with it, we can just pop back to backtrack. So why are we doing this? So if I am at index number 0, so I have to make use of all the characters one by one at position 0. So for the first time, A will be used, it will be pushed back into current, and the function will be called, and all the strings starting from A will be pushed back into answer eventually. Now I pop back that A from here, and I push back B at the first index. Again I call back, and all the strings starting from B gets calculated. So in this way the strings get backtracked. So here I want to say is I will get all strings starting with A, then we will have B, and so on. So this is for index number at the index position. Fine. When index is 1, then we will have all the characters, all the strings starting from A, and we will make use of B first, then S at the first index, then G at the first index, and so on. So now how do we check whether we have already used the number or not? So for that, I'm making use of bit masking. So basically, an int can store, I have like 2 to the power 32 range. So for each bit position, it can be either 0 or 1. So if I say 0 represents unused and 1 represents used characters, then we can just mark each of them, and suppose the like the number of such combinations will also be equal to 2 to the power n. Fine. So now we'll start with 0. So by default, like in the beginning, none of the characters have been used. So what we will see is whether the bit at the bit at the ith position from the right is signed or not. If it is signed, then it means that that character have already been used, and if it is not, then we can make use of it. So if this gives 1, that means that we cannot make use of that character, so we just need to negate it. So this gets true only when the character at the ith index is not used, that is the bit mask at that position is not 1 and it is 0. So once we use it, we will also need to mark it as 1 while passing for the next iteration. So bit mask 1 shifted by I positions. Okay, and that solves our problem. We just need to current will be empty. We will start from the 0th index. The bit mask will be also 0, and finally we will have our answer. And now let's return this answer. One thing also is there, that we have to return the permutation in lexicographically increasing order. So what we want to do is sort this answer array, and yes, let's compile it. If index is greater than, oh, it's int, not string. Okay, it is giving correct answer. Basically, I have given a custom input here. Anyways, let's submit it. It gets accepted, and hope you liked this solution and understood the concept of bit masking as well. See you tomorrow.